by part. Tabular method. So the way you work it is you're given an integral and you have to choose the parts that are u and dv. Then you apply the formula. The integral of u dv is equal to u times v minus the integral of v du. Okay, so normally we choose u, we choose v, and we go through this process of figuring what we choose u, we choose dv, we calculate u prime, we calculate v by taking the integral of dv, and sometimes we have to do this over and over again before it works. So here's the idea for using the table. So here's the table, and you're going to have two columns. This one is the derivative column, this one is the integral column. In the derivative column, you list the value that you chose to be u, and in the integral column, you list the value you choose to be dv. On the next line, you calculate u prime, and here you calculate the integral of dv. On the next line, you calculate u prime, and over here, the integral of dv. And you, again, that's double prime. And you continue like this until eventually you're going to stop. Now the trick is to know when to stop. When you're finished, you take a line, you draw from here down to there, from here down to there, and if you get to the end here, you bring an arrow back. Now you're going to put alternating signs starting with plus, minus, and down here when you come back the other direction, whatever sign comes next, in this case it will be the plus integral. So this is the idea basically, this little table that you're going to create. And there's going to be three different cases that we're going to cover. First we'll call this case A. And this is a case where your derivative column, it has the u prime, it has the u double prime, but eventually it goes to 0. Okay, so this is how you handle a case where the derivative column goes to 0. Example, the integral of x times cosine x dx. We're going to integrate by parts. You're going to use the LIAT. Is it ET or AT? It is TE. Sometimes it's ET. Method for choosing u and v. So we're going to start off by saying let u equal x, because that is an algebraic function, and dv will be equal to whatever's left over. In this case, it's the cosine of x dx. So it's a good idea to tell me, as a matter of fact, it's imperative that you tell me what you chose to be your u and what you chose to be the dv. Now we'll make a table. We get our two columns, the derivative column, the integral column. In the derivative column, we let u equal x. In the integral, we let dv equal the cosine of x. Don't write dx, just cosine x is fine. Now, right below that, we're going to have u, the derivative of u prime, that's going to be 1. And then down below that, the derivative of 1 is 0. So you see how the derivative column went to 0. Now for the integral, we take the integral of the cosine of x, and that's the sine of x. And then we take the integral of the sine of x, that's negative cosine x. And we stop there. Now we can check our work to make sure the integral column's good by just taking derivatives upward. Negative cosine x prime is the negative of sine x, which is positive sine x, and then the derivative of sine x is cosine x. So we went up and found that everything was kosher, everything worked. Okay, now let's draw our arrows going down, down, and at the bottom, going across. Let's alternate signs, plus, minus, and this is plus the integral at the end. It's not always going to be plus at the end. It's whatever it turns out to be as you're going down. Okay. Thus, here's our conclusion. The original question, the integral of x times the cosine of x dx, is equal to, okay, from the table we have a plus x times sine x, and we have a minus 1 times negative cosine x. Then we have a plus the integral of negative cosine x times 0 dx. Okay, so the integral of 0 is 0, so this is just equal to x times sine x. Minus and minus is plus cosine x. And now you add your c, your constant of integration, and you're finished.